So, in case you didn't get that right over there, I record my lectures. For somehow you have not heard of the fact that I record my lectures. Notice that I record my lectures. And interesting to note, this is my first lesson to you. Some states are what we call two-state consent laws, and other states are what we call two-party consent laws, and some states are what we call one-party consent laws, which means that's how many parties need to consent to a recording. I forget which Pennsylvania is, but I consider it polite to everybody know that we're recording stuff. You are more than welcome to bring in a tape recorder and make your own audio recording. Just let me know that you're doing so. I do this because, because flu happens, colds happen, getting sick happens. And if you are if you're sick, I don't want you to drag yourself to class and pay half attention while infecting all your classmates and possibly me. So just send me a message and then stay home and catch up on the lecture when I post it on YouTube. So I will post most of the. If you miss anything in here, we'll be posting I'll post it on YouTube later. That said, if you got my email last night, we don't really do too much lecturing in this class. By the way, I should probably make sure this is 2168, right? Good. I'm in the right place. I'm sure you've all had that dream where basically it's the final exam and you've learned that there was a final exam, there was a class you were supposed to be attending all semester and you totally forgot about it, and now it's the final exam, and so you now know nothing. Well, I have that same dream, only I forgot to teach that class all semester. So, now, this class is what we call a flipped classroom, which means actually today we are actually going to start doing some work. It also means that I won't be doing a lot of lecturing in this class, because I've already done that. And I've been running this class this way for a couple semesters, and the response to it has been overwhelmingly positive. So over here under pages, right, on your Canvas website, there's a bunch of links. First link is to a YouTube video done by the YouTube channel Crash Course. Wonderful people, Crash Course. They have a link to, and this just simply, I've embedded their video on data structures, which is like a 10-minute overview of all the stuff you're going to learn in this course. It's by no means a replacement, but it does tell you a lot of what you're going to learn in this course. Here is a link to all the code that I'll be doing in class, or I've done. It'll be under the destruct folder, which has all these, folders of just different, code that I did while coding up stuff. So in-class recording, anything that I do over here and upload will be under this one. This is where basically if you missed class for some reason or you want to review what we did in class, you'll find those recordings here. Here's, though, where the meat of the course is, which is this page, lectures. And each of these over here is actually a playlist. Not sure why it's not loading. Oh, there we go. Each of these is a playlist that we did. Each of these is a playlist of basically a week's worth of content. So, they basically vary from about, an hour to up to 2 hours. We average around 1.5 hours a week. So the idea here behind the flipped classroom is that here we're doing basically essentially in a traditional lecture, I'm doing one-to-many teaching, which is basically saying I'm over here yammering, and maybe you get a couple minutes to interact with me during the class time where you ask me a question. And then I get annoyed because you're asking so many questions and I have a lecture to get to, people. It's not necessarily great. It's basically I'm just simply performing for you guys, and that doesn't necessarily translate to the best way to learn, especially, you've got giant distraction machines in front of most of you, and in your pockets. So you lose track for a couple minutes. What is he talking about now? Right? Done that myself multiple times. I was a terrible student. Anyway, So instead of that, I've recorded all these lectures. They're the individual videos are fairly short, and I pieced them together. Like over here, when I go over linked lists, let's just go over this. Like these are like 7 to 15 minute videos a piece, which means that basically you can watch an entire video and get the subject matter of that video in a sitting. And basically, each week you just watch one of these playlists. They're titled like week 1, week 2, week 3, week 4. So you watch that, and I'll let you know what you're supposed to be watching. And then, so you do the idea here is you do your lecture watching normally when you would be doing your homework. And in return, when you do your lectures, that's when you normally do your lectures, that's when you're going to be working on most of your homework with all these wonderful people around you. The idea here is that that I'll be able to go around to you and help you like this is an additional lab section. You'll be able to ask me questions. You'll be able to work with your peers. You're going to be able to get a lot done. We'll also be doing more stuff like quizzes in this class just to make sure you're caught up to stuff. But that's basically the structure. For these videos, just try to have them, watched by the end of the week because, some of you might, be coming into class later. Some people don't, This first week is primarily review of stuff you already know, okay? Object-oriented programming. The next week is array lists, which if you're coming from Professor Fiore's class, right, which most of you are, right, because I think he teaches all the 1068 sections now, you should have already tackled array lists in some shape or form, right? You've probably learned how the array list works, but not necessarily internally. Have you worked with generics yet? Nope. So that's the big thing we're going to be basically adding to this, which is array lists of integers or array lists of strings. So that's the next step. So you'll be able to see so we have all these things for you. And if you want to get ahead, you can. You're more than welcome to get ahead in this course. We also we benefit from some cross. Turns out I didn't need anything. I thought I didn't have an HDMI cable,
Gotcha.
and I found them all hidden, scrolled away in there.
They hide them. I don't know why they do that.
You're
good to go?
Yep, I'm good to go. All right. So we also benefit from actually that from a graduate course, an online graduate course that we did. You'll notice that these videos look a bit more high professional or these thumbnails look a bit more high professional than you normally get from, just recordings. And that's because we did some recording for our graduate course. So basically each of these have a nice 2 to 3 minute primer of what that week is about. And then the rest of the week, for the most part, is, is going to be stuff like this, where basically I am recording. Some of these are just stuff I still have to update to my new way of doing things, which is that I got myself a green screen and a nice camera and nice microphone and re-recorded most of these things. So most of them actually end up looking something more along the lines like this.
So that was humiliating. I just lost 40 minutes of recording because I forgot to mute, or rather
So there we go. So,
Here, inserting.
And that's most of and since most of this class is, just doing
to
a lot of,
this.
It's doing a lot of coding. Makes sense that this kind of format works. And the nice thing is that you can pause it. All right, so syllabus time, and then we'll get to work. I know. Normally the syllabus is the first thing we do, but I want to just explain how this class works. Okay, syllabus, right? You found the place and the time. For some reason, I'm required to put that here. And I even put the wrong time and place in, so it doesn't really matter. And by wrong time and place, I just didn't update it because nobody bothered reading the syllabus to figure out the time and place. You find out the same way I find out, which is the central course listing. Generics. Inheritance, array list, time complexity, linked list, stacks, queues, recursion, trees, heaps, Huffman trees, sorting algorithm, hash tables, and graphs. So basically that's all the stuff we'll be covering this semester, which sounds like a lot. It's really not too bad. This must be that's why. No. I have the old syllabus here. New syllabus, right? I just didn't pull from Git from on my laptop. That's what it is. There we go. Okay, apparently I didn't upload the new syllabus either. Okay, whatever, doesn't really matter. Your labs are on Friday. Both of the labs are Friday at the same time. You have our textbook is data structures, abstraction, and design using Java. It was written by two professors who work here who are now completely retired. The textbook, though, is actually good. I actually like it. If I didn't like it, I wouldn't use it because that reeks of nepotism. And we will actually be using all the materials except for chapter 3 and 9. Chapter 9 will go into some detail, but I don't cover it just simply because of time constraints. Same with chapter 3. You can get the second edition, by the way. Second edition, the only difference is that the third edition's chapter 4 is chapters 3 and 4 in the second edition, and then the third edition has some nice features that were introduced, in Java, such as Lambda expressions, and it goes over that. So it goes over some newer Java features, but they're not required. So you can get whatever financially works for you. Geez, why didn't this update? Let's see. Because I did change the CD teaching, git pull. By the way, if you haven't started using Git, you totally should. Or some subversion. Because the dog ate my homework excuse just doesn't work in computer science. It really doesn't. There we go. See? I had it. I just didn't upload it. So I'll upload this. See, here's your lab sections. They're both simultaneously at the same time. My office hours are from 3 p.m. to 4 p.m. today and 4 p.m. to 5 p.m. tomorrow. Also by appointment. So I tried to have some hours that would work for everybody. And then if you can't meet me then, just send me an email. I'll either meet you on campus, or if you're commuting, I can meet you, via, voice. We have Zoom here, which is actually really nice. Zoom is one of those corporate web meeting kind of stuff. But what's really nice is that you can screen share, and I can actually take control of the screen if you let me, which means I can type on your computer, which is nice. And so I can do some simple markups. So our TAs, I still have to track down Jeet, but Jovan, you here? Yeah. Did I get your name right? Yeah. Okay. So this is one of our TAs. So you can go to any. So there's going to be both TAs will be listed here. I still have to get office hours. Jovan's is listed on Tuesday from 12 to 2. By the way, this is day 6 in America for you?
Let's say that.
Yeah, day 6. So he's been here less than a week, and he's already TAing. So so that's pretty impressive in my book. So his office hours listed here. Now, both Jovan and Jeet, I'll put their office hours here, and you can go to either of them, even if they're not your TA for the course. If their office hours work for you, you can go to them, right? Again, with my office hours, you don't need an appointment to come and see me. So, for attendance, we expect you to show up for both the lectures and the labs. If you're not going to show up, just send me an email. If you miss a quiz, just let us know so you can make it up. Right? The quizzes are fairly simple and straightforward. They'll be done on Canvas. They're essentially, and they basically are also your participation grades, because you'll get some freebie points for taking the quiz. So they're not worth that much, but they help. Okay. Also, you want to show up to the lecture, because I have been prone to mentioning what's going to be on the exam up to and including the exact question that will be on the exam. So. And some people still get it wrong after that. So, I guess they just weren't there. Again, illness, just don't show up to class if you're sick. I totally understand. I have a toddler, and I don't want to do that. If you want, you can email me for my chicken soup recipe. But all right, academic honesty. So don't copy and paste stuff from online. I catch somebody every semester doing it. Just don't do that. And really, if you need help, ask one of these wonderful people around you, right? We're going to be in this together. We're going to be working on these together. The main thing is that I want you to be able to work on it and understand it. If you're in doubt, like I found this nice for loop that does this for me, right? Provide a citation to it. At that point, it's no longer plagiarism because you've cited it. Plagiarism is when you present somebody else's work as your own. The worst I can do in that case is go, I need you to do this I need you to do it this way, so rewrite it this way. That's the worst I can do at that point. Right? Working with others and creating your own unique solutions is not cheating. We encourage you to ask your classmates for help and to collaborate. Right? Copying someone else's work is cheating. Right? When in doubt, provide a citation. Okay? If you have a disability of some sort, like you need extra time or you need a note taker, go through DRS. That way I can know. Feel free to come and speak with me about any accommodations that need to be made, though. I'll be happy to speak with you on one-on-one. So grading, so I do curve at the end, but I curve the range. So for last semester, I think an 88 and above was an A, right? So generally you get a lot of A's and B's in this course and very few C's, and we didn't get too many. And the amount of F's in this D's and F's in this course go down throughout this. Been going down mainly because we've been doing a good job of filtering out students who would get D's and F's in 1068. We do use plus minus grading, but mainly that's to bump a grade up rather than pull a grade down. So those 88, the 88 and 89, those were A minuses, right? So as opposed to the 92s being A minuses. So your final grade is the average of each item, weighted accordingly. So quizzes are 10%. That's also your participation grade. Your labs and assignments are the same thing. We're starting on our first one today. I guess even if it's just for a bit. That's going to be worth 25% of your overall grade. Exams are the bulk of the grade. It's just the way it is. But the way it works out is that basically these two grades, with this making 35% of your grade, provides a huge buffer for your score. Because as long as you're doing your assignments, you're going to end up with an A in both, 90% in both of these, at least. So if you miss a quiz, just come by me. During office hours, and you'll be able to make it up. Okay. So labs and assignments. This is just. Don't submit stuff that's stupid. So the turn-in process is as follows. Submit it online to Canvas. This gives us an electronic paper trail for your assignment, essentially saying when you've completed it, and so we can know if it's late, how late is it? Because I do have a formula for lateness, which is your grade is equal to score times 0.95 to L, where L is the number of days late. And simply put, you lose 5% per day that it's late. Not 5 points, 5%. Which means that first day, it's a 95. Second day, it's 90.25. So it goes down a bit. So this is kind of an exponential decay until we hit about 50%, and then generally I cap the losses at 50%. So if for some reason you decide that that actually the latest expansion of World of Warcraft, assuming people still play that, is really what you need to do, and then you realize that was a terrible idea, you can still get 50% for all that stuff you missed. Anyway, the second step is that you've got to get your grade is that you've got to demo it to me or a TA, either during class, during lab, or during office hours. Okay? That involves showing me that your program works, explaining pieces of this source code, possibly changing it a bit on the fly, but basically we want to see that you understand it. It's not a one or nothing deal, by the way. If you're unsuccessful at demoing, I just tell you to go away and come back when you're more prepared to demo it. This is not so much of an issue for this class as in other classes, but generally try to demo it within 2 weeks of the turn-in date. Exams, we can expect 2 exams and a final. That will take place the exams take place during the labs. So that way you can get the full 2 hours. So that'll happen during around week 5 or week 6, and then week 10 or week 11, depending on the flow of the semester, whether or not there's snow days or not, But this one will basically cover all the way up through linked lists. This one will cover all the way up through binary search trees. Final exam, because I find out about the final exam the same way you do, which is clicking here, then looking on the big table about when the common final is. This will be a common final, and guess what? I'm the person in charge of this class for the entire department, so I get to write the final exam. So the big thing here is that because it's a common final, it has a reputation for being difficult. That may not make sense, but what it is that final exam is on the Tuesday of the last week of the semester, which means that basically that it is the second to last day of finals. Which means by this point, you're already exhausted. You already had the weekend to study, and you spent it studying for the exams on Monday, so you're completely unprepared for Tuesday, or you worked on the projects that you had to do throughout the week, so you're basically you're like, well, I've done also all right in this class so far, so I don't really need to study. Wrong. Study for this one, like you would for the other 2 exams. So it's mainly just because, but I believe that a lot of students have trouble with it because just because of the timing of it. Now, we have been able to raise the average since I got here from like 50 on the final to like something more acceptable, like a 75. So, also note that if you have more than 2 finals on the same day, there's official university policy that allows you to request a professor to move, and you take it some other time. Read this link about your rights and responsibilities because it turns out you have rights as a student. I didn't know that. All right. So, right. I'll upload this syllabus after class and the changes to it. But you know from your schedule when you're supposed to be attending your labs. All right. So with that, let's go ahead and dive into our first assignment, which is a review assignment, and it's a great way to open up the course. So first off, note that if you are bored and you want some time to do stuff, and you have something to do, you have time to work on stuff, there's this extra credit. Its due date is by the end of the semester, please. And it's why not take the time to teach yourself regular expressions, which are useful in this course. You don't need them to succeed in this course, but they're super useful to learn. And the first week of class, when nothing much is really going on, is a great way to great time to learn. Our assignment is Fox and Rabbit. Your code can be downloaded here. You get a bunch of starter code. And you can work on this assignment for as it's a review. You can, and it's and you work on this one in groups. So unlike other ones, find some other poor student here and pair up with them to work together. So this is an assignment I blatantly stole from another professor. It's a great assignment. It's a review of content from 1068, and it's a program that basically it's got a GUI. If you haven't worked with GUI, don't worry. You don't need to worry about graphics or anything like that. The program takes care of all that for you. The premise is pretty straightforward. So let me go ahead and actually download the assignment, and I'll go ahead and then just start showing you how things work with it. So, boop. Yeah. So, extract to desktop, because why not? Close. So, let's go ahead and run. So the main program is Rabbit Hunt. Yeah, I recently reformatted this computer, so I just need to change it to open with Geany. Set as default. There we go. Compile. Most of the time I'll be using, let's see, what's it called? IntelliJ, but this one's a simple enough one that I can just run like this. All right, and you run Rabbit Hunt, you compile it, and it looks like this. And if you're running a Unix-based system, it will just show up like this without any grid. So just go ahead and start it by pressing either step or run. And this is our program. So the red dot is the fox. The fox's job is to run and find the rabbit and eat the rabbit. It does so by landing in the same square as the rabbit. Each of these guys makes one move at a time. Right? The rabbit's job is to avoid the fox and not get eaten by the fox. Right? So the fox moves around, hunts for the rabbit, tracks it down, and goes to eat it, as it just did. See, the fox eats the rabbit after 64 turns. Okay, and then the board is completely randomized, by the way. Starting positions. So we sent this up to run again. And there it goes. And again, the fox is going to be looking for that rabbit and will try to eat it. There, 25 turns. Rabbit's gone. The rabbit's goal is to survive for 100 turns. At that point, it gets away from the fox. Okay? Now, here you're going to be playing as the rabbit. You have only one job, and only one thing to alter, which is the rabbit class, right? Which is, and you have actually only one method to write. So here's your rabbit. It is an animal, right? So in other words, the thing that moves around on the board. By the way, I should probably explain one more thing. These green things are bushes. They block line of sight. And also these, there's a physical border on the wall in this space. It's not like Pac-Man where if you run off the end, you appear on the other side, right? Okay. So fox extends animal, right? The fox has a bunch of code in it, and decide move, blah, blah, blah. And it just basically has all this commented move where it just basically says, hey, I'm going to look around, see the rabbit. If I see the rabbit now, I'm going to go and chase it down. And if I can't see the rabbit, I'm going to pace around looking for it. That's essentially what a fox does. The rabbit strategy, if it can be called that, is terrible, which is that I'm going to decide move, and I'm going to move in a random direction, which essentially equates to standing still on average. Not a great strategy for long-term survival, in my opinion. So you want to basically make something a bit simpler. Something a bit more successful. Your grade in this assignment is out of 120, and we decide it by running the grader, which we compile it, run it, which is basically we take the percentage times you live out of 300. 2 times out of 300 or 0%, meaning this is a 0 grade by default. So interestingly, if we tell it to just simply return model.stay, I believe. Is that how it goes? Yep. If we just tell it to stay still and not move, it manages to survive a bit more better. Notice that it survived 1% of the time, and your grade is 10 points. So your grade is determined by out of 120, is that you get 20 points this time just for demoing, just so you get familiar with the process, as well as 100 points for the actual survival rate, or rather the square root curve of your survival rate. And the way the square root curve works is that we take the square root of the survival rate, and then we multiply by 10. So in other words, if your rabbit survives 64% of the time, well, square root of 64 is 8. 8 times 10 is 80, so that would be 80. And your overall score would be 100 points out of 120, right? Because 20 points per demoing. What this does give you is that it gives you diminishing returns. So basically, at some point, right, once you get to 81, that's a 90 for the grade, right? For the survival grade. Because square root of 81 is 9 times 10 is 90, right? So above that, it starts you get to decide how far you want to go with that. There isn't really a survival rate of 100%, or rather, it's a bit tricky to get that way. The other thing is that I should mention that surviving is, it's completely random. This time I survived 4 times out of 300. So, it can be a bit finicky. When you run it, you can do it out 300, or you can, up the number of iterations for this so that it's less random. 41 times out of 3,000. So, and that gives you a bit more accuracy for your score. So, so that's essentially what we need to, what you want to do with this. Now, how does this all work? Well, we can see a bit of how this works with the Fox code, and I'm going to go through this. Now, you do not want to replicate the Fox code. That's probably going to be your first step. Do not replicate the Fox code. The Fox code is predator code. It is seeking out something, and it needs to be much more advanced. The prey code is very, very simple. The correct solution, which survives in like 90% of the time, is like 10 lines long. It is not particularly difficult in terms of that. Although basically you can, and I'll get into that in a second. There are basically 2 strategies you can go with for this. Okay, so let's go ahead and run Rabbit Hunt one more time. So if I go with step. So first, I think the rabbit moves, and then we'll see the fox. And notice that basically it's now shooting a laser out. Actually, what that is that it's looking. This is calling a function called look, which basically it uses a for loop to check all 8 of its cardinal directions, right? Which is north, south, east, west, and all those diagonals. And so what that does is that basically that beam runs until it hits something, and then it bounces back and tells it, okay, you saw a border, a bush, a rabbit, right, in this direction. It tells it what it is, and then it can call another function called distance to let it know how far it is to something. So those are your basically the 2 look functions. Now they look, and it looks in cardinal directions. Notice that basically my code said for the rabbit not to move, so it's no longer moving. Right? So now the fox saw it, right? It's checking around. It says, I still see the rabbit, so I'm going to move forward towards it. Same thing over here. See the rabbit? Boom. No. So that's essentially the look function, and I've got all the functions listed in the PDF that you can download. They're also in the model function. A particular note is model.turn, which basically means you don't have to, and the point here is that you don't want to say, well, if it's to the north of me, then I want to go this way. If it's to the south of me, I want to go this way. Model.turn just simply says if it's in direction I want to go maybe I want to turn I4, which is the number of, and 4 being the 4 45-degree turns. So that would be directly away. And you can basically just, and what you want to do is you just have to change this function. In fact, you're not allowed to change anything else but this function, or rather this class. You can add variables if you need to. There are 2 general strategies, which is dodging line of sight is strategy number 1, and what that means is basically, if you notice, basically if the fox is looking like this, and then it goes to look like this in this direction, you've got this entire triangular area where the fox is blind. It can't see it. And also note that basically that this is a turn-based game, so it's possible for the fox to basically look around, not see the rabbit, move, and now it would be in line of sight with the rabbit. Moving is the last thing you can't do. You can't look after you move. So the rabbit then can look, see the fox, and then move out of his line of sight. So that's strategy number one, basically staying out of line of sight, and then if it does see you, try to shake the line of sight. Okay, that's strategy number two. Strategy number two is very similar, and that's to kite the fox. And if you've played an MMORPG, you know what kiting means, but for those of you who don't, kiting is the strategy where one player gets aggro on a monster, meaning that it gets the monster's attention, and says, chase me, chase me, chase me, while the rest of the party pelts it with rocks or something. So here, the idea is that, if you've got a respectable distance between you and the fox, you can just simply say to the fox, chase me, chase me, chase me. And because we move at the same speed, I just have to let you chase me for 100 turns and not crash into, like, a bunch of bushes or something. Which is a bit trickier, but you can essentially, if you look at the fox's code, you can exploit it and go, oh, if I do this sequence of moves, we are now in an infinite loop, and I win. So that's another strategy you can do. Both of those strategies are viable. And there's probably other strategies, but those are the two that I've seen the students have success with. So, without further ado, go ahead and get started. If you don't have a laptop, pair it with somebody who does. You'll probably want to bring a laptop if you have one. If you don't have a laptop, or you don't have a laptop you can rely on, come and speak to me. But for most of these, you will be working with other people, right? So, but again, if you don't have a laptop, just come, in general, come and speak to me. And if it's not a laptop you can code on, come and speak to me as well. So, all right, and I'll be around basically meeting all of you.